All right. So the whole idea behind EOQ or economic order quantity model is try to find a balance between these two costs that are at tug of war. The first one, holding cost, is on the one side and the ordering cost on the other side. Again, I want you to understand what exactly holding cost is and what exactly ordering cost is. Holding cost is the cost of holding the inventory. Ordering cost is the cost of ordering every time. Okay. All right. Let's try to develop intuition behind holding cost. Suppose every time you order Q, this Q could be anything. In our previous example, we have a demand of 2,000 cases every week. So the whole year we have a demand of 104,000 cases every year, given that there are 52 weeks a year. So this Q could be anything. You could order all 104,000 every week in the beginning of the year, right? Whatever that Q is, the amount you order. Remember, we started with the notion that the demand is constant. If that is the case, what's going to happen? Well, the first thing you will notice is if you order Q and if the demand rate is constant, the demand will the first day the order arrives, it is the inventory is at Q and it starts decreasing as a straight line, right? Because it's constant, and at some point you'll reach to zero, right? You started at Q and you'll reach to zero, which means if given that this decrease is a constant rate, the average inventory is gonna be 1/2 of the Q. 1/2 of what you ordered is gonna be your average inventory. Half the time you would have more than half Q. Half the time you would have less than half Q. So on average, if you order Q, let Q be whatever the number. If you order at one point, say you decide to order 1,000 cases every time. If you order 1,000 cases every time, on average you'll hold 500 cases. That is, half the time you'll have more than 500 cases, half the time you'll have less than 500 cases. Okay, does that make sense? So if you decide to order 1,000 cases at a time, when the cases are over, you'll order such that another 1,000 would arrive right at this time. You'll see this pattern going on. So if you decide to order Q, your average inventory is half Q. Okay, that's the first part. So if you on average hold half Q inventory, what is the cost of holding half Q inventory? That's what we want to find out. Okay. Now this is where I want to go a little bit on tangential and explain a little bit. So normal day to day, holding cost is expressed as annual holding cost rate. Annual holding cost rate. That is, people say the holding cost is 20% or holding cost is 30% or something of the sort. People use numbers like that. Percent. So this 20% of what? 20% of cost, the unit cost of the inventory item. Unit cost of the inventory item. Inventory item. So if your beer costs $10, right? If your beer costs $10 and if you have a holding cost of 20%, that means it costs you $2 to hold the beer for 1 year. To hold one case of beer. So if the holding cost is 20%, and the cost of the beer, one case of beer is $10, what you're saying is it will cost you 20% of that $10 to hold the beer throughout the year. Okay, so that's the reason we have to do this calculation, is because holding cost is always expressed as this I, that is annual holding cost. So we have to define CH, that is cost of holding, which we can call it as IC, where I is the rate and C is the per unit cost of the product. Okay, all right, that's how holding cost is. So if your average inventory at any given time is half Q, Q being the amount of you order, your total holding cost, your total or annual holding cost is going to be this part. This is your average inventory, half Q, times your CH, what was the cost of holding each unit, right? So your annual holding cost is going to be half Q, which was your average inventory, times by CH, what was the cost of holding each unit. Then let's go to our next part, the annual cost of ordering. Annual cost of ordering. Well, this part, annual cost of ordering, this part is slightly more involved. The first part is easy. So if you order, say, X times, and it costs you, say, Y dollar to order every time, the annual cost of holding would have been X times Y, right? So let's see what this X would be. So your total demand for the whole year is, let's call this D, big D. That's how much your total demand. In our previous example, the total demand would be, so each week you had a demand of 2,000. There are 52 weeks, so your total demand would be 104,000. So if your total annual demand is D, and you decide to order Q units every time, because we have been calling it that unit Q. So if you decide to order Q unit every time, you're gonna order D divided by Q times, right? So if you had a total demand of 104,000, and every time you order 1,000, you'd order 104 times. So D by Q is how many times you're going to order. Well, let's call this ordering cost. Every time you order, let's call this cost of ordering, CO. Okay, the annual cost of ordering now is D, which is your annual demand. Q is the amount you're going to order multiplied by CO. Okay, now that brings us to a more interesting part. So we have basically built the model. Let's change the color while we are here. So that means our total cost of ordering, TC, is our first part, cost of holding, that is half Q, that is how much you order, that could be any number, times CH, cost of holding, plus your total demand per year, big D, divided by how much you order, times CO, cost of ordering. Now let's just try to put some numbers to this. Okay, let's just try to put some numbers to it. Suppose in our example we are working on, suppose D is, as we have said, 104,000. Suppose cost of holding is, say, $2, right? Suppose cost of ordering is $32. Just throwing a number there, doesn't matter, right? If this was what it was. Now suppose you decided that you want to order Q equals to 8,000 every time. Suppose you decided you're going to order 8,000 units every time. What would your total cost be? Well, your total cost would be half. Then you're going to replace 8,000. You're going to replace Q with 8,000. 8,000 times your holding cost is $2 plus your total demand is 104,000 divided by your Q, you decided to order 8,000 every time, times your cost of ordering is $32. Well, you do the math, this comes out to be 8,460. Let's do it one more time. Suppose this time you decide to order 5,000 every time. Suppose your Q is 5,000. What would happen? Well, again, the same formula. Half your now Q is 5,000 times 2, which was your ordering cost, plus 104,000 divided by 5,000 into 32. This comes out to be 5,666. So how much should you order every time? So what is that magical number that will make this total cost the least? Right? Obviously, ordering 5,000 every time, 5,000 cases every time is better than ordering 8,000. So are we going to do it with every queue possible and find out which one will be the lowest? That would be pretty tedious, right? So the trick is this. Now, the trick behind the reason for this trick is a little bit complicated, and I'll leave that for the time being and maybe explain it another time. But the idea is you want to find the queue such that your ordering cost is equal to your holding cost. So our holding cost was half Q CH, cost of holding, and we want to make this equal to our ordering cost, which was DQ divided by multiplied by C0. So you want to find that particular Q, that particular Q that would make this equation hold. You want to find this particular Q so that, remember, this is a tug of war. You want to find that particular Q such that these two are exactly the same. Well, you can either take my word for it and say we can solve it to Q star, that particular Q is given by this formula is 2dC0 divided by CH, or I can show you how this really comes out to be. Well, this is a pretty easy calculation actually. QCH, so we want to get rid of this 2 first. So to get rid of this 2, we have to do cross multiplication. It comes out with 2dC0 divided by Q. Now remember, we want to find out that particular Q, so we have to collect this Q. So this comes out to be Q square, this 2Q, equals to 2dC0, and this CH comes on this bottom, CH, or Q equals to 2dC0 divided by CH. So we will call this Q star. So if you find a Q star such using this formula, that will balance this cost of holding with the cost of ordering, and I'm claiming that this will minimize our total cost. So let's see what would happen in our case, right? In our case, that means Q star would have been 2, our yearly demand is 104,000, our ordering cost is 32, divided by our holding cost is 2, so our Q star comes out to be 1824 cases. So you should order 1824 cases every time so that your total ordering cost is minimized. So you can find out what that total ordering cost is using our earlier formula, which was TC equals to half QCH plus DQC0. I'll leave this as an exercise for you. Half, our Q in this case now is 1824. Our CH, our holding cost, is $2 plus our D was 104,000 times Q is 1824 times our cost of ordering is $32. I'll bet this number will be smaller than the two values we have seen before. In fact, I'm claiming this value you will get will be the smallest possible with any combination, any choice of